to talk about displacement. So displacement, we usually represent it by the symbol S with a vector on top. So displacement here is a vector quantity. So where do we use displacement? We use displacement when an object experiences a change in position. Let's say object was previously here, then it is now there. So if there's a change in position, we can describe the change of position using this kinematic quantity, displacement. Okay, it comes from the word displace, and if you use it in English, it actually means being moved, being forced to change position. Like people say, the orang asli that live in this forest are being displaced due to deforestation, something like that. Okay, I'm not really good in English, but yeah. So how do we quantify this displacement here? We take the final position and minus with the initial position. So as you can see in this equation here, the vector displacement here is equal to the final position, the vector of the final position minus the vector of the initial position. So position, we have discussed it in the previous video. Okay, so we are going to use back an example. It's a motion in the x dimension, and at time 0 you have a person standing here. Then this person starts to run. When time starts, it runs towards this point, which is x equals to 4 meter. Then after that it makes a U-turn. The moment it makes a U-turn, we call it T1. And then this person run back towards the opposite direction, but pass through the origin as well. Okay, so we label this part time 3, T3, because I labeled the moment where it passed through the origin as T2. So it goes like T0, T1, T2, T3. So initially it was standing here, then running towards T1, then make a U-turn, run towards T3. So this arrow here is representing the motion of this person over here. So if we try to determine the position at T0, T1, T2, T3, at T0, the position will be at 0. So the position x0 is equals to 0. So if I write x0 over here, it means the position at time equals to at time 0. Okay, and then at time at T1, the position will be x1. Okay, so this x1 here we have already discussed in the previous video to be 4 meter towards the positive x direction. For T2, again, it's at the origin, so x2 is equals to 0. Whereas at T3, the position x3 is 7 meter towards the negative x direction. We have discussed this earlier in the previous video. So we are quite clear about how the person move and where the person is at time 0, time 1, time 3, time 2, and time 3. So let's try to do something regarding displacement. Okay, yeah, we rarely write this way because we usually write in the components of position. In this case, we usually write as x0, x1, x2, x3 without the arrow sign, indicating that it's just an x component of this position here. Okay, so let's find from T0 to T1. So from T0 to T1, I'll remove all the irrelevant stuff. From T0 to T1, let's try to determine the displacement. How do we determine displacement? Again, it's final minus initial. So where's the final? The final will be T1, right? Because T1 is a later time. The initial is where? The initial will be this point because this is the earlier time. So we can take final minus initial, x1 minus x0. Okay, so once we know that, we can start to do calculation. But the issue we have here is x1 here has magnitude and direction. Then x0 here, of course, it has its own magnitude and direction. So of course, direction, when we talk about magnitude and vector, we have magnitude and direction. So if you want to add or minus a vector, what should you do? You should resolve to its components when you're solving it. So you should have your x component and your y component. But since all this motion here is in the x component, it should resolve only to the x component. So once you resolve the x component, you have Sx, and it will be equals to x1 minus x0. So this one is the x component of the position. This one is the x component of displacement. So Sx, S subscript x. So now as a matter of substitution, x1 we know is positive 4, then minus x0 is 0. So you get answer to be 4 meter. So once we have done that already, we can bring the answer back into vector form. We know this 4 here is positive, means that it's in the positive x direction. So this one is 4 meter towards the positive x-axis. So what does this displacement mean? This value here means that this object from time 0 to time 1 has experienced a change in position 4 meter towards the positive x-axis. So experience a change in position 4 meter to the right, because to the right is our positive, toward our positive x-axis. So experience a displacement to the right for 4 meters. Okay, let's try another example. Now let's try from t0 to t2. Okay, so you move from here, go towards this position here, then do a U-turn, come back to the origin. So in this case, we remove all the unnecessary information, and this is the only information we need. We don't care how it gets from t0 to t2. We only need to know at t0 he or she is here, at t2 he or she is here. That's the only thing we need to know. We don't need to know how we get from t0 to t2. We just need to know at t0 where am I, at t2 where am I. Then you can solve the problem of finding displacement. I don't care about the path. Okay, so again, our displacement will be x2 minus x0, because whereas the final moment it's t2, so x2, the earlier times is t0, so the initial position is x0. So again, do the x component, resolve it to the x component, then you have Sx equals to x2 minus x0. So since both of them are at the origin, so 0 minus 0, so you get 0. So you bring it back, you get 0. Okay, so what does it mean? Even though the object does experience some movement, okay, as you remember, it moved towards x equals to 4, then turn back, make a U-turn, turn back to t2, right? Even though it does experience some kind of motion, but if it ends up at the same place as where it starts, then the displacement will be equal to 0. Because again, we don't care how he or she gets from t0 to t2. Between t0 and t2, what happens between t0 and t2, we don't care. We only need to care at t0, where is he or she, at t2, where is he or she. We don't care about the in-between. Okay, so that's t0 to t2. Another example, let's say you want from t0 to t3. Again, we don't care about what happened between t0 and t3, so let's remove it. We only care about where is he or she at t0, where is he or she at t3. So this is the only information that we need. So let's try to find the displacement. The displacement is again, final is x3 minus initial x0. So if you resolve, then you should get Sx equals to x3 minus x0. So now x3 here, it's 7 meter towards the negative x direction. So if we change it into x component, because it's towards the negative x direction, you should have negative 7 for your x component of x3. Because you resolve this vector into its x component, and it's pointing in the negative x direction, therefore you should have negative. So your answer for Sx here is negative 7 meter. So just by seeing what's the value of Sx, if you see Sx to be negative, you know this displacement, this x component of displacement is in the negative x direction. And in our case, negative x direction is to the left. So it's from seeing negative 7 meter, you know this is 7 meter to the left. Okay, so now let's bring it back here. So if you bring it back into this, we write the magnitude as 7 meter, magnitude always positive, magnitude of a vector. Okay, sorry, magnitude of a vector always positive, then the direction is towards the negative x-axis. The negative here is the direction, right? We represent it as the direction here. We don't we don't put in sign into our magnitude here. Okay, but how do you actually go from negative to positive? Well, actually, if you remember, if we do the proper resolve, there's x and y, right? After finding the x component and the y component, how should we combine them together? We should do Pythagoras theorem, right? We do Pythagoras theorem to combine them together. Then we use tangent theta to find direction, right? In this case, the direction is clear cut, so we don't need to do tangent theta. But if you are wondering how to get from -7 to 7, that's where the Pythagoras theorem comes in. If you do Pythagoras theorem, this step is not required, but if you do Pythagoras theorem, the square here and the square here will change the sign of the components. So previously it was negative, but after going through the Pythagoras theorem process, you get back a positive value as its magnitude. So this is how you go from negative to positive. Okay, so this is from T0 to T3. Let's move on. Oh, okay. Before we move on, I have shaded this part over here because in an exam or in your working, this is a part that we care about the most. Unless they ask, determine the displacement of the object from T0 to T3. Then you might need to end up writing this answer over here to show the magnitude and your direction. But if you are in doing a calculation, this is a part that we care about the most. The way you write this, the sign you have, and the answer is the sign. Okay, so let's continue. Let's say I want T1 to T3. Now as you can see, I'm not starting from the time 0. So technically displacement from any moment to any moment, it's fine. I can do it from T2 to T3. I can do it from T1 to T3. Anything is accepted as long as it's an earlier time and a later time. Okay, so for that, we remove all the irrelevant stuff. Just need to know T1 to T3. So now, the displacement will be x3 minus x1. So x3 is the final position, x1 is the initial position. Okay, we don't care about there's an earlier time T0. If we say from T1 to T3, our earlier time is T1. So our initial position is x1. That's it. We don't care about what happens earlier than T1. We don't care about what happens later than T3. We don't really care about what happens in between T1 and T3. Just at T1, where am I? At T3, where am I? Okay. So finding an x component, we will have sx equals to x3 minus x1. Then you calculate, this is -7 because x3, the component is in the negative direction, minus x1 here is equals to 4 because x1 is in the positive direction. So it's minus a positive 4. Okay, so -7 minus positive 4. So when you calculate that, you get -11 meter. So what does it mean? -11 means by it's 11 meter, but negative means it's in the negative x direction. So as you can see, this motion here, it's 11 meter towards the left. Okay, again, you put it into Pythagoras theorem to change it to positive, change it to a positive value, and bring it here, 11 meter towards the negative x-axis. So as you can see here, if you calculate how long is this displacement vector here, you say this displacement vector here is 11 meter and it's towards the negative x-axis. Okay, again, when you do it in your working, this is the part that we care about the most. But if they ask you to determine the displacement from T1 to T3, then you might need to write give your final answer as magnitude and direction. Okay, so these are a few examples of how to determine displacement.